Welcome to the second half of partial fractions with prime quadratic factors. So this time around, we are looking at the indefinite integral, the integral of 2x plus 1 over x cubed plus 3x squared plus x minus 5 dx. So again, the first thing that we need to do is factor the denominator. X cubed plus 3x squared plus x minus 5. If we try factor by grouping, we would have x squared times x plus 3 plus 1 times x minus 5. These remaining factors don't match. So factor by grouping doesn't work. If we apply the rational factors theorem, and some trial and error, you wind up getting that x cubed plus 3x squared plus x minus 5 is equal to x minus 1 times x squared plus 4x plus 5. So we are looking at the integral of, our numerator is 2x plus 1. And our denominator is x minus 1 times x squared plus 4x plus 5, and then dx. This x squared plus 4x plus 5 is a prime quadratic factor. We are as simplified a denominator as we can get. So at this point, we'll go ahead and run partial fractions. So we are going to split 2x plus 1 over x minus 1 times x squared plus 4x plus 5 as capital A over x minus 1 plus, again, if we have a quadratic in the denominator, we need a linear in the numerator, so we will do plus capital BX plus C over x squared plus 4x plus 5. Clearing the denominators, we get that 2x plus 1 must be equal to A times x squared plus 4x plus 5 plus BX plus C times x minus 1. From here, I like to always solve for my A out front if possible. So we can make that x minus 1 go to 0. If we plug in x equals 1, then we will have a bx plus c times 0. And so we have 2 times 1 plus 1 is equal to a times 1 squared plus 4 times 1 plus 5 plus bx plus c times 0. This means that 3 is equal to a times 10. And we get that a is equal to 3/10. So we can simplify our previous equation to 2x plus 1 is equal to 3/10 times x squared plus 4x plus 5 plus bx plus c times x minus 1. At this point, we'll go ahead and expand and match coefficients. So the left-hand side, we are still looking at 2x plus 1. On the right-hand side, we are looking at 3/10 x squared plus 6/5 x plus 3/2. Then we have a plus bx squared minus bx plus cx minus c. So this becomes 2x plus 1 is equal to, we have a 3/10 plus b times x squared. Then we have a 6/5 minus b plus c, all multiplying x. And finally, we have a 3/2 minus c for our constant term. So matching coefficients, there's an invisible 0x squared on the left-hand side. So we can match that 0 with a 3/10 plus b. So we have 0 is 3/10 plus b, means that b better be equal to negative 3/10. If we use the constant term as well, we have a plus 1 matched with a 3/2 minus c. So we have 1 is equal to 3/2 minus c. That means that c better be equal to 1/2. So we have at this point that our 2x plus 1 over, we have x minus 1 times x squared plus 4x plus 5. This is equal to, our a was 3/10 over x minus 1, plus we have then a negative 3/10 x plus 1/2 all over x squared plus 4x plus 5. Putting this all together, we need to find the integral. We are looking at the integral of 2x plus 1 over x minus 1 times x squared plus 4x plus 5 dx is equal to 3/10 times the integral of 1 over x minus 1 dx plus plus the integral of negative 3/10 x plus 1/2 all over x squared plus 4x plus 5 dx. From here, we know the first integral. The second integral, we are going to apply completing the square and use substitution. So our first integral of 1 over x minus 1 dx is just the natural log of the absolute value of x minus 1. The integral of negative 3/10 x plus 1/2 over x squared plus 4x plus 5 dx. This is equal to the integral of negative 3/10 x plus 1/2 all over, completing the square, x squared plus 4x plus 5 becomes an x plus 2. All things squared, that's x squared plus 4x plus 4. So we just need a plus 1 and then dx. If we apply u sub, if we set u equal to x plus 2, then we have du is dx. And we are looking at this is equal to the integral of -3/10 times x would be u minus 2. So -3/10 times u minus 2 plus 1/2 all over u squared plus 1 du. This becomes the integral of -3/10 u. Then we would have a plus 3/5 plus 1/2, or plus 6/10 plus 5/10 becomes plus 11/10 all over u squared plus 1 du. We can split this as -3/10 times the integral of u over u squared plus 1 du plus 11/10 times the integral of 1 over u squared plus 1 du. The first integral, if we set v equal to u squared plus 1, dv would be 2u du. And so u du is 1/2 dv. We wind up getting that first integral is a -3/10 times 1/2 times the natural log of the absolute value of u squared plus 1. And that second integral, we have plus 11/10 times that is just tan inverse of u. So 11/10 times tan inverse of u, and then plus c. I realized I forgot a plus c earlier for my natural log x minus 1, then plus c. All right, from here we can plug back in our x. U was simply x plus 2, so we have a -3/10 or -3/20 times the natural log of u plus 2 squared plus 1, sorry, x plus 2 squared plus 1 plus 11/10 times tan inverse of x plus 2 and then plus c. So our big integral becomes the integral of 2x plus 1 over x squared plus 4x plus 5 dx is equal to, we had 3/10 times the integral of 1 over x minus 1 dx. So we would have 3/10. Let me update my screen, I apologize. All right, so we were doing the integral of 2x plus 1 over x squared plus 4x plus 5. We previously found that was 3/10 times the integral of 1 over x minus 1 dx, or 3/10 times natural log absolute value of x minus 1. So we have a 3/10 times the natural log of the absolute value of x minus 1. And then it was plus the second integral, which we just found that integral to be -3/20 times the natural log of the absolute value of x plus 2 squared plus 1. So -3/20 times the natural log of the absolute value of x plus 2 squared plus 1. And then we also had plus 11/10 times tan inverse of x plus 2. And then, of course, our plus c. So partial fractions. Sorry, I missed a factor in my integral. We were looking at the integral of 2x plus 1 over x minus 2 times x squared plus 4x plus 5. Or x minus 1 times x squared plus 4x plus 5. Sorry about that. All right, so this is how we can go about finding an integral. We had a cubic denominator that had a linear factor and then a prime quadratic factor that was not just a simple sum of x squared plus a squared. And it requires a little more depth to it, but it is completely possible to do with the various techniques that we have learned so far.